That means if we give a input data of whose size is 200 images, the model works, and for the same architecture, even if we give 6,000 images, the model still works. So those are with those objectives we started off, and this is the methodology. Data collection is standard. So like I said, we focused on the Bay of Bengal region, and so we took 4 tropical cyclones, Amphan, Yas, Fani, and Pailan for this particular study. The data are freely available from Mosstack, and the important thing is the cadence of this data set is 30 minutes. So every 30 minutes we have an image. Actually, not one image, but we have 6 images because this is multispectral data. So in a variety of IR bands and visible band. So the architecture designers, we have developed a CNN. I'll come to that in the next slide. And so what we are defining is, we're defining that a model is the CNN plus the data set from a given band. So we took 4 storms here, like I mentioned, and then we considered 4 bands. I think it's written here, yeah. So these are the 4 cyclones and the 4 bands in the IR region. One is IR 1, 2. This I think is in the infrared region around 2 to 10 microns. So different bands here. So we took 4 bands: IR 1, IR 2, middle infrared, and water vapor. And so annotating these images was really easy because we know when the cyclone happened. So the timeline, from this date and time to this date and time, all the images are cyclonic, and the images before and after that date would be non-cyclonic. So that is how we choose the cyclonic and non-cyclonic images for training. We ensured that there is a balance in the data set. So we took, although we have a lot of images for non-cyclonic part, we still took only a number which is comparable to that of the cyclonic images. So those 4 storms, each storm in 4 bands. So we have 16 models. Basically, the 16 data sets. Then for each storm, we combined all the 4 bands together. That means, we combined all these images from all the bands. That was another model. So 4 models more. And then in another case, we combined all the IR1. So in the same wavelength region. So IR1 of each of these storms. So those are 4 more models. And in the end, we combined all the images that we had for all the 4 cyclones and all the 4 bands. So ultimately we have 25 data sets. So for the same CNN architecture, we are saying that we have 25 models. So these are sample images here. So we concentrated upon the Bay of Bengal region. We took only a part of the entire image. We did not use the entire map that is seen here. It's from -50 to +50 latitude, and I think 20 to 130 longitudes. So we didn't use the entire region, but we only concentrate upon the Bay of Bengal region here. This is the CNN architecture. You're all experts. Combination of convolution and max pooling layers, followed by 2 flattening fully connected layers. So ultimately, you're getting one output which says 0, 1, or 1, because this is a binary classification. So it's either a presence or an absence of the cyclonic storm. So the important thing here is, the total number of parameters that we're actually training in using this architecture is only 1.9 million. So that's pretty small, actually. So these are the results, say 0.99. That's really, what should I say, a number which is, it seems to be like, physically not possible. It's too good to be true. But then that is what comes out. And what I believe is, we really were wondering why this should happen. So number of times, I asked Somijit to check it out, and any number of times he was doing that. He even performed the what is that called, the cross validation part, using different set of non-cyclonic images, but still the results were the same. So what we gather is, if you actually look at the sample images, so if there was no cyclone, basically, you see the thing is dark, right? So, but if there is a cyclone, for example, this is an example here. So the entire cloud is covering up the entire image. So, the image is entirely different. So this this drastic difference in the cyclonic and the non-cyclonic images is being learned extremely well by the model. And since it is just binary classification, so it appears to be performing really good. And the other thing is as well, like, it's probably we don't need such a deep learning architecture. We can actually use a much simpler model to achieve the required result. But then the idea is, to go for prediction of cyclones. So we need to, develop these deep learning architectures to first do a binary classification, then go for a multi-class classification, then for a prediction of the cyclones and its severity. So we are continuing with the deep learning itself. These are some of the confusion matrices. You can see that they are doing really well. Your false positives and false negatives are, not practically, they're really zero, and very small numbers occasionally. The training and the validation accuracies and loss of some examples of some of the models. So we are sure that the model is not overfitting, etc. So this is a comparison with the previous models. So similar studies are conducted in the North Indian Ocean and the North Pacific Ocean. So the accuracies there were around of these in the order, and the number of parameters were actually too huge. In one of these cases, the number of parameters is greater than 2 billion. And in another study, it was 25 million. But in our case, it is just less than 2 million. So I believe that we have advantage in a number of ways. Our accuracy is really good. Number of trainable parameters is very small. One thing which we can actually further do is do a combination of these. We can apply our model on some of these data and see what type of accuracy we are getting. Or we can actually take our data set over Bay of Bengal and apply these methods and see what type of accuracy we are getting. So that is something which we can do for future. Actually, that was the comment that I received during the presentation there. So this is the summary of the talk. So we use the INSAT 3D images with the focus on the Bay of Bengal region, and performed a binary classification to detect presence or absence of the cyclone. We achieved an accuracy of 0.99. And we established the scalability of the model architecture because we didn't change the architecture for the different inputs. In one case, when we used only one single band for a single storm, the number of images was only 200. But when we merged all the storms and all the bands, the number of images was 6,000. So still the model was working really well. So scalability is established. The number of trainable parameters is less, therefore reducing the computational costs. And so all this, it paves way for further investigations of multi-class classifications and predictions using AI, ML, and DL models. In future, we are just not these four, but we are going to include more storms also. So that's the future plan. And the important references here, I'd like to acknowledge Mosstack, Israel MOES for providing free access to INSAT 3D data, and IIIT Kalyani, for sponsoring me to go all the way to Nagpur and present this paper and get it published. So thank you, and I'll be very happy if any of you have any questions. And questions, comments, suggestions. Hello, I was audible, right? Yeah. Okay. I was wondering, maybe I was just speaking to myself. And excellent. Yeah.
No,
Once
wonderful presentation, but no question.
no question. Oh God. I'd appreciate if you have some comment, maybe, or suggestion for future work, future scope. Yeah.
No, wonderful presentation, but no comments.
Other students, Madhuchanda? All right.
Yeah, ma'am. This is new. This satellite image work. So, ma'am, nice work.
Okay. Okay. Thank you. Thank you. Yeah, I'll convey all the best wishes to Somijit. He's doing excellent, actually.
Yes.
Yeah. Yeah. Thank you. Thank you. All right. So this was good actually. More students, all of our students should go for variety of conferences because this is where there's a lot of networking happening. You listen to very senior people. There was a lot of keynote speakers. They're speaking about all the latest work that is happening in the field. I am a very I'm as good as you people are. I mean, like in the way of saying new to the subject because I don't know much about computer vision and image processing, but I did pick up a lot of jargon. So it is good. So I would encourage all the students, to go attend conferences and, you're all publishing papers that I know. So keep up the good work, but also, try to go for conferences. So, you develop your network, you talk to people, you learn a lot. All right. Okay. Vishala madam, any comments?
No, thank you for sharing it with all PhDs. It's a very good idea. Earlier we had only faculty gathering.
Right.
I appreciate your idea.
Yeah. Okay. No, I thought it's good, no, because this is, this is research, and all of us are researchers, irrespective of whether we're a student or a faculty. All of us are researchers.
We should continue.
Chiranjit, you're going in and out. You don't have any questions for me? Okay.
And I think we can start the culture even for PhD students also. Whoever is attending the conference, after conference, you can just arrange such a presentation so that other students
Correct.
also get benefited.
Correct. Actually, I would suggest the other way around. Like if it is a PhD student, actually, it is better to have a dry run before going to the conference. So they are prepared with the type of questions that might be
Okay, that will
asked.
be
Yeah.
good try.
Yeah.
And already published paper, so there is no chance of repeating the things or taking the idea.
Vijila ma'am, your voice is
Correct.
so low that we can't hear properly.
Oh, sorry. My mic was out.
Yeah.
Now it's audible.
Yeah.
What Uma ma'am is suggesting before conference, once your paper is accepted, before giving the presentation in conference, you can arrange this type of presentation among the PhD community so that you can have a trial kind of thing with the possible questions may come in the conference. So that way we can start now. Now we are having a good number of PhD students.
Correct.
So that practice we can start and everyone will be benefited.
Right. And we'll know, right? All of us, we should
Yes.
talk to one another at an academic level, so we know what the others are doing, sitting in the next room, and it's possible that we
Yeah.
can give some suggestions. Sometimes interdisciplinary work. This is how ideas come about.
Definitely.
Even recently, one paper Chiranjit presented in the conference. So Chiranjit also may present to all of
Definitely.
you one day. Yeah, that
Definitely,
also.
that will be very good. Yes.
Share the link and whoever is available definitely will join.
Yes.
Exactly. Okay, so thank you one and all for giving me your time and listening to us. And all right, see you all around. See you next time. Bye bye.
Bye.